Hello everyone, myself Professor Rajendra Ghiwari from Department of Electrical and Electronics Engineering, Angli Institute of Technology and Management, Belagavi. Today we'll be dealing with power system protection, which is a 7th semester subject, and in that we'll be looking at the introduction to power system protection. Fundamentals of power system protection. So the purpose of an electrical power system consists of the generator, the transformers, transmission and distribution line to generate and supply the electrical energy to the consumer. Now, the power system should be designed and managed to deliver this energy which is generated to the utilization point with both reliability and economically. The capital investment involved in the power system for the generation, transmission and distribution is so high that proper precautions must be taken to ensure that the equipment not only operates as early as possible to the peak efficiency but also must be protected from the accidents. So we have seen a typical electrical power system wherein we have a generator which is going to generate the power at the generating station, and the power is transferred to the a power transformer where the voltage is going to step up, right? And again, step up voltage is being transferred to the receiving station. Wherein in the receiving station, the voltage is going to again step down to the certain value. Again, from the receiving station, it will be delivered to the various receiving stations. Now, from the receiving station, it will be going to the substations which are near to the places. Again, in substation, the voltage is going to step down. Now, again from the substation, it will go to various substations. Again, from the various substations, it will be going to the distribution station, wherein the station consists of a distribution transformer, which are located near your house. So those are called the distribution transformers. Right. So for each and every step, or for each and every element, such as for generator, transformer, and for the substations, there should be a protective element for any kind of fault taking place. If the fault takes place, that element should be protected. Right? The normal path of electric current is from the power source through copper or aluminum conductors in generators, transformers, and transmission lines to the load, and is confined to this path by insulation. So the electric current is supplied by the means of a conductor. It can be copper, it can be aluminum. It is used in either generator, transformer, or in a transmission line to the load, and it is confined by a insulation. The insulation, however, may break down either by the effect of temperature and age or by a physical accident, so that the current then follows an abnormal path, generally known as a short circuit or a fault. So this is the cause of a fault. So the conductors which are present in the generator, transformers and the transmission line are already insulated. But there's a chance that there may be a breakdown in the conductor, or there may be an effect of temperature, or by physical accident the current follows the abnormal path, which leads to a fault. Basically, the overhead transmission lines are bad conductors. They are not insulated. Air will be acting as an insulation for that. What is system protection? System protection is the art and the science of detecting the problems with the power system components and isolating these components. So protection is needed not only against the short circuit but also against any other abnormal condition taking place in the power system. So the examples of the abnormal conditions can be an overspeed of a generator and a motor, or over voltage, or under frequency, loss of excitation. So these are the abnormal conditions which can happen in a power system. So the system should be protected for a safer usage. Need for the protection. To protect the system equipment against the short circuit, over voltage and over current. To protect the system equipment against the abnormal conditions such as overspeed of generator and motor, under frequency, loss of excitation, overheating of stator and rotor of the alternator. To protect the system against the atmospheric effects such as lightning stroke, falling of tree branches on conducting path. So the heavy current which is associated with the short circuit would cause the damage to the equipment. If suitable protective delays and the circuit breakers are not provided for the protection of each section of the power system. Short circuits are usually called as faults. Say the failure of connecting path due to break in the conductor is a type of fault. So failure of connecting path due to break in a conductor is a type of fault. If the fault occurs in a power system, an automatic protective device needs to isolate the faulty element as quickly as possible to keep the healthy section safely. So during the typical the power system section, if a fault occurs in any of the line, an automatic protective device is going to isolate that faulty element from the healthier part, and that has to be done, or else there is a huge loss of heavy equipments in the transmission line. It may affect the generator side also, it may affect the transmission line, it may also affect the distribution, substation, receiving station also. So usually the protective system includes, so this is where we have to include a protective systems in a power system. So the power system includes a circuit breaker, right? We'll see about this for the next module. We'll discuss, there are many types of circuit breaker which are available. Transducers, which sends the which transform one form of energy to another form of energy. So it is a current transformer and a potential transformer and a protective relay to sense the fault and to isolate the faulty section of the power system from the healthy section. So basically relay is a protective device which is going to sense the fault or the abnormal condition, and it is going to alarm the circuit breaker to trip the circuit, making sure that the healthier part is safe. Now what is a fault? Any abnormal operating state of a power system is known as fault. Fault in general consists of a short circuits as well as the open circuit. Open circuit faults are less frequent than the short circuit faults, and often they are transformed into short circuits by a subsequent events. So fault can happen by any means. Either it can go by the breaking of the conductor, or by breakage in the insulation, or by the overspeed of the motor and the alternator, failure of insulation. So these are the causes of a fault. Nature of faults. Faults are caused by the insulation failure or by crack in the conductor path, which results in damage of the equipment. Fault in the transmission line is caused by overvoltage due to the lightning stroke or external object falling on overhead lines. Faults on insulators. There can be chance of lightning stroke happening in insulator also. Birds may cause the faults on overhead lines if the bird body touches one of the phases and the earth wire. A poor quality of the system component or the faulty system design. If the connectors are broken, there is a failure of the connecting path and the connector becomes open circuited. If the broken connector falls to the ground, it results in a short circuit. So, so the joint failure of the cable or the overhead lines are also a cause of a failure of the connecting path. The opening of one or two of the three phases makes the system unbalanced. Therefore, unbalancing of the lines is not allowed in the operation of a power system. So, in case of cables, transformers, generators, the cause of fault are the failure of solid insulation due to aging, the heat factor, the moisture factor. There could be a mechanical damage or accidental contact with the earth, flash over due to the over voltage, etc. Sometimes the circuit breaker may trip due to error in the switching operation or testing or maintenance work. Certain faults occur due to the poor quality of the system component. Hence, the fault can be reduced in by improving the system design and providing a good quality of protected systems for better operation and maintenance. Types of faults. Two broad classifications are symmetrical faults and unsymmetrical faults. So power system faults are of two types: open circuit fault and short circuit fault. The open circuit fault has one connector open, two connector open, or three connectors open. So basically any of the three phase can get open. That is an open circuit. Short circuit has two types again: symmetrical fault and unsymmetrical fault. So in symmetrical fault, it is a three-phase short circuit fault or three-phase to the ground fault. And in case of unsymmetrical fault, there is single line to ground fault, two-phase to ground, that can also be called as double line to ground fault or line to line fault. So these are the fault types. Okay, so these are the three phases now. Okay, so in symmetrical fault, what happens? Either the line to line or the three lines are shorted each other. There's a occurrence of fault. Or all these lines are shorted with respect to earth. That is again a symmetrical fault. Now in case of unsymmetrical fault, we have line to ground. This is your first, any phase, any of the phases with respect to ground is a fault. And two lines to a ground, the two phases to a ground can be also fault. Line to line is also fault. So line to line is a symmetrical fault which is most dangerous. Line to ground is a unsymmetrical fault. Line to line is again unsymmetrical fault which is least and more dangerous. Then double line to ground, that is two phase to the ground. It's again unsymmetrical fault which is dangerous than the line to line and the line to ground. Symmetrical faults. So a three-phase fault is called as a symmetrical fault. There are two situations. All three phases may be short-circuited to the ground or they may be short-circuited with each other without involving the ground, as we discussed. Unsymmetrical faults. First is the line to ground. Second is two phase to ground. Saying that double line to ground. Third is phase to phase. So in single phase to ground is what? A short between any one phase and the earth is called a single phase to ground. It may be due to the phase conductor breaking of the fault or failure of the insulation. So any one of the phase can either break or the insulation can get a failure. Two phase to ground. A short between any two phases and earth is called a two-phase to ground fault. Phase to phase, a short between any two phases is called a line to line or phase to phase fault. Open circuited fault, this is caused by break in the conducting path. Such fault occurs when one or more phase conductors break or the joints in the overhead lines fails. Winding faults, the faults occur on the alternator, motor and transformer winding. In addition to these type of faults, there is one more type of fault, namely the short circuiting of turns, which occurs on machine windings. Again the same figure, the three phase, line to line, line to ground and two lines. So balanced and unbalanced. So we have studied what is balanced condition and what is unbalanced. A system is said to be balanced when all the three phases are equally apart by an angle of 120 degree with respect to one another. So here you can see that all the three phases are having equal angle. Here it is 120, 120, 120. But in unbalanced, if any of these conditions are not satisfied, so all the three phases are unbalanced. They are not equally apart by an angle of 120 degree. So again, a short circuit calculation, fault types, single phase to ground. So here you can observe, so there are three phases. First phase, second phase, this is the third phase. Okay. So first, second, third. So now this one is the ground one. So single phase to ground. Now short circuit calculation faults type line to line. So this is first phase, this is second phase, this is third phase. So line to line fault. Now short circuit calculation fault types for three phases. So all three lines will be included. So this type of fault, which is a symmetrical fault. So first phase fault is going to happen with the second phase fault. Again the same is going to happen with the third phase fault. Now what are the effects of fault? What are the effects? So the dangerous type of faults is a short circuit and is going to have the following effects on the power system. The heavy short circuit current may cause the damage of the equipment. Arc associated with the short circuit may cause the fire hazards and the possibility of the fire spreading to other parts of the system if the fault is not isolated quickly. Due to the fault, there may be a reduction in the supply voltage of the healthy part. So the heavy current can damage the equipment. Arc, which is associated with the short circuit, can cause the fire hazard, which is going to spread again to the different parts of the system if the fault is not quickly isolated. And due to the fault, there is a reduction in the supply voltage. Short circuit causes the unbalancing of the supply voltage and the current. There is a loss of stability due to the individual generators in power stations, and they may not synchronize to each other. Fault may cause interruption of supply to the consumer also, thereby causing a loss in the revenue. So these are the effects of faults taking place in a power system. So fault statistics, percentage distribution of faults in various elements of a power system. So here these are the elements which are used. Overhead lines, we have underground cables, transformers, generators, switchgears, CT are nothing but the current transformers. VT is a voltage transformer. This is relay control equipment. So you can see the percentage of faults for various elements. So we have maximum higher number of percentage which are taking place in overhead, that is 50%. And next we have switchgears. Switchgears are nothing but your relays, circuit breakers, current transformers, CTs, PTs, the lighting arresters, isolators. These are your switchgears, a kind of switchgears. And next is the control equipment, right? Transformer have 10%, underground cables have 9%, generator will be having 7%. So total highest fault which is taking place is over a transmission line. Thank you. In next session, we'll be looking at the protection system, protective system zones, and the different types of protecting qualities which are required for the protection. Thank you.